this number is odd, you have to divide it by 2 in the formula. You're going to end up working with the fraction. Not anytime, but often. Often would be an odd fraction to work with. Yes? Yeah, so yeah, as long as your fraction is there, you can consider the decimal form, so you put it in the right spot. That's fine. All right, let's go through the steps. The first thing we did was y-intercept. It's going to be 0, 4, as shown in the last value here in the equation. Yes. Next step. You can't do much graphing if you don't know where the middle of the parabola is. So your next step is find the middle. What's the formula that gives us the middle, the axis of symmetry, Cassidy? That's right, x equals negative b over 2a. And in this equation, I can see that a is negative 1, the number in front of x squared. B is negative 3, the number in the middle. And C is 4. So it's negative, negative 3. 2 negatives there. And another negative. So that's going to be positive 3 over negative 2. Is that what you have marked as negative? I think I'm going to stop there and start drawing my graph. I'm going to stop there and go to the x and y axis and start to get a picture of what I'm looking at. The whole purpose of all of this work is just to get a nice parabola. So I have this point, which is the y-intercept at 4, and I'm at, my dashed line is at 3 over negative 2. Which is negative 1.5. So I go to the x-axis between negative 1 and negative 2, full dashed line. That'll be the middle of my graph. So now that I have that dashed line now, I can reflect across it. What's our next move? After you find what x is, what do you do? Brian? Set up your chart. Yes, you can make a table. Before I set up my chart, there's one more thing I'm going to do. Yeah. Find y. Did you already plug in? I haven't plugged in yet to find y. The vertex is my next move. Plug negative 3 over 2 in to find the y value. So it's going to be negative 3 over 2 squared minus 3 times negative 3 over 2 plus 4. So I'm going to keep the negative sign in front. I ignore it. It stays in front. I'll square this. Squaring a fraction, square the top, square the bottom. So that's going to be 9 over 4. Negative 3 squared is a positive 9. 2 squared is a 4. The negative sign is anti. Negative 3 times negative 3 is a positive 9. Making that 9 over 2 plus 4. Questions so far? So my next move is to get a common denominator. If you really want to be successful, you should know how to do all this fraction work by hand. So I got negative 9 over 4 plus 18 over 4 plus 16 over 4. Because I have to multiply that top and bottom by 2 and this top and bottom by 4. And we'll do fractions all year. So working them now and getting comfortable with them now is like an investment for like second quarter, third quarter, fourth quarter. They don't go away. Yeah.
You get the same answer if you just did negative 9 over 4 plus 9 over 2 and then you add whatever that was to 4.
Yeah, you can do it one step at a time.
You do it.
Yeah. So like he's suggesting just get a common denominator here. Not mess with that 16. Just add these and add 4, yes.
Will it come with the same answer?
Yeah, if you do it right. Yeah, for sure. So this will be 9 plus 16. Did you get 25?
I got 25 over 4.
Yep, that's it. So when I add across the top, I get 25 over 4. So now I have a vertex. I have a center point. Negative 3 over 2, comma, 25 over 4. Just get comfortable with your fractions now. May as well. May as well not suffer for 3 more quarters stressing out about fractions. You can do that. So 25 over 4, that's going to be 6.25. Right there. Nope, a little bit higher. Right here. So the table. Next is the table. In the middle of the table, you have to have your vertex. If your vertex isn't in the middle, you're not going to get a U. Negative 3 over 2, 25 over 4. Does anybody feel like they really understand what points should go in this table? 2 points to the left and 2 points to the right. Anybody feel like they got it right? Mark, you give it a go. Uh-huh.
You just get a decimal of negative 3 over 2.
I'm actually not gonna like think about it that hard. I'm gonna just look here and I'm gonna pick this number and this number. Okay.
So if you get anything to the left?
2 points to the left, any 2 points to the left. And then 2 points to the right. This one, negative 1 and 0. Yeah, I'm not gonna try to like necessarily add 1 here or something. Yeah. Yep. So I'm just gonna go right to negative 1, negative 2. No. On the left would be negative 2, negative 3, negative 1, 0. Who's got a question about the table? Okay. Hey, Trey, you plug negative 3 in and tell me what you get out. Your whole group. You, Brian, and Brian. Negative 3. Aiden, Isabel, you guys, your whole group, plug negative 2 in. Tell me what you get out. Alex and Ava, you guys do negative 1. And all of the rest of you pick 1. Maybe negative 3. That's probably the hardest. Negative 3. And you can check. I haven't assigned anybody 0. What's the 0 going to be? 4. We already know that one. Did you do it, Isabel? What'd you get? Okay, keep going. How did it go, guys? Did you get a number? I got 4. But you must have had a debate. I think you ended up on the wrong side of the debate. This is how it goes. So I would do this exponent and get positive 9. And then negative 1 stays in front. And then negative 3 times negative 3 is positive 9 plus 4. All right, very good. Discussions over there. What did you guys get for negative 2? Yes, yes. Does anybody have a question about their work? Why they're not getting the same number out? The numbers on the board are correct. The numbers in the groups are good. Plot your points and see your U shape. So try to make sure it's a curve at the top. All right, number 2, identify domain and range.
Is it like continuing or is it just that? Like, are those points mean like it's not because there's no arrows?
No, I got arrows. I got arrows.
Oh, right.
Yep, these go. It goes down forever, infinity down there. Just right through the earth to the other side, and then through the universe and forever. It does not stop. Can you picture it going down through the earth, all the way to the other side, and then to the universe? I wonder where it will come out. Where would it come out? That's true. What would we do then? It come out pretty quickly, I guess. How flat is it? Is there a theory about that? How flat is it? Okay, so domain's gonna be the same for all of these parabolas. All of them. It's all of them. All the numbers for infinity can be plugged into this equation. The range is not so unlimited. It's limited. It's a limited range. So there's 2 options. So I'll give you like a little note. It's either going to be y is less than or y is greater than. So these arrows point down. If the arrows point down, you do y is less than in your range. I don't know why I use this yellow color. Can you see it? You can't. Arrows point down. Oh, I have that wrong. Arrows point down, go here. You say y, so our arrows point down, so we're going to say y is less than. But if your arrows point up, your range has to be y is greater than. So in this case, y is less than 25 over 4. That's the max. That's the max point. It doesn't go higher than that. So as another note, we could write down that the range is the same as the y value in the vertex. Because that's the highest point. It starts to turn when it hits the vertex. So the vertex is either the highest point or the lowest point. So that y value should be identified when you identify domain and range. When you're done with that, you can just get out your worksheet. Most of you have it out. I'm going to walk around and give you credit. I offered extra credit earlier, so I can do that again. Okay, let me just. Did we do number 2 together in class? Yeah. So we're just going to work on number 3 up here. Is everybody good if I erase this? Aubrey? But I wasn't in. Is it fountain architecture? I guess it is. It's also engineering a little bit. What piece of architecture models a parabola? An archway. Every archway, not every, most archways, if you were to graph them and make a model, their model would be a parabolic equation. All architects, they have like a plan before they build it. Most importantly though, what's the most common archway? We have like a lot here in our area. Bridges. Bridges are often parabolic. Okay, oh, that's one of the worst parabolas I've ever drawn. Okay, so bridges are often parabolic, and so a quadratic equation, as simple as it may seem, models the archway of all of these parabolic. They're all over the world, parabolic bridges. The x-intercepts. If you know the x-intercepts, you know the distance across the bridge. Okay. There's other places. I mean, parabolas are actually used in math and science all over the place. Have you guys seen that movie, Hidden Figures? It's about the mathematicians who were women back in the day. Yeah, it was about NASA. You honestly raise your hand if you've seen it. Sometimes I give extra credit for it. Okay. For watching the movie and they're ready. Anyway, so there's a big problem. It's about NASA. Not at this moment, but maybe at some point. There's a big problem at NASA. There's like a piece of equipment, a ship. I think there's people on it, and they're not going to land in Earth. And so this one female mathematician, she figures out if they change their equation going around Earth is an ellipse. And she figures out if they change the equation to model a parabola, that it brings the equipment home. And that was real NASA problem solving, going from an ellipse to a parabola. In the parabola, x-intercepts, if you look at this as the x-axis, x-intercepts often give you real-life solutions. So for that reason, zeros of a function, x-intercepts, these are considered the solutions to parabolas. So your new goal is to find x-intercepts. That's applicable in math and science, knowing what the x-intercepts are. Also, anything falling down to Earth is the time and gravity takes a parabolic equation. You have balls floating through the air like basketball. That's a parabola. I'm going to show you kind of a cheesy video of all the parabolas in the world. I think you should. I wish you see it. It's our long one. It's not good. Right now, you know, like you don't want your floor ready up. Right now, phosphorus. Can you just see it? Okay, no, I can tell you. I'm not. Alright, page 223. This is if you want. You can just use this. You don't have to open up a. But if you want to see this in your book, it's page 223. Let's. Yeah, page 2. You don't have to get it out though. You can just look up here. Yeah. Let's do number 1. Number 1 gives you the graph. Does this parabola? Okay. Let me just identify the. It says determine the solutions. As a reminder, solutions are x-intercepts. One of the weirdest things about math curriculum is that they just like refuse to tell you what they're looking for and they use different words, right? If they would just say, use the graph to find x-intercepts, like 100%, 100%. But they don't. They say solutions and they want you to know, memorize that means x-intercepts. Does number 1 hit the x-axis? It does not. This is an example of a no solution graph. If there are no x-intercepts, then there is no solution. Number 2, can anybody see the x-intercepts where you're sitting? -2 and 5 are the solutions. Now, may I for a moment jump forward and show you the future of our work? I don't want you to get overwhelmed. Well, if you're already overwhelmed, maybe just don't listen. But I'm going to show you where these -2 and 5s come from. Here's our problem. So back in August, week 2, I think, week 1, week 2, we worked on factoring. Does anybody remember? Okay, so we would have to find two numbers that multiply to -10 and add to -3. Anybody remember that? -5 and 2. You guys remember doing this? Rewriting these? Now, if you solve these, you set both factors equal to 0 and solve these little baby equations. What do you see? These numbers, what do they match? They actually match these numbers. Do you see it? Do you see it? It's all connected. None of this is random. So the graph shows us the x-intercepts. The x-intercepts are solutions. So we're working towards solving without graphing. But we're letting you graph first, see the solutions and what they look like. But shortly, we'll just give you the problem without the graph and have you rewrite it and solve it. So these are called zeros, roots, and x-intercepts. What's the answer for 3? Looks like -4. There's only one answer. So sometimes there's no answer. Sometimes there's 2 answers. And sometimes there's 1 answer. Lots of possibilities. No. You know what has 3 answers? A cubic function. Okay, the number of solutions is connected to the exponent in the equation. Facts. That's a whole like property. All right, you guys, we are gonna go ahead and do number 4 for classwork, and then we're done. This is it. Graph the. We're gonna make a graph. So we're still graphing, we're not factoring. I was just showing you. I was just stepping into the future with this. Right now we're just graphing. Let me erase this actually. Allison, do you know what we're gonna do first? No. So this problem, the reason I picked it is so that you could see what it looks like when there's a number missing. I put a 0 in. The textbook didn't type it, but I put it here to your benefit. Here, A equals 1, B equals 8, and C equals 0. So when there's not a number there, it's an invisible 0. So the first thing we're supposed to do is identify y-intercept. This is going to come back to be really important in just a minute. What do you do after the y-intercept, Baden? Oh, you don't have your hand out. I should have found someone with their hand out. Someone still have your hand out? What do you do after you find the y-intercept in your graphing? Anybody else? You go axis of symmetry. Thank you. You need to know the middle of the graph. Are we good if I write AOS? Are we good? Axis of symmetry? Have we done this enough? So the formula for axis of symmetry, negative b over 2a, is this memorized by now? Let's see, how many times did we do it yesterday? Twice. We did it once for homework, 3. We did it once for bell work, 4. This is our 5th time. Can you memorize the formula in 5 times? I'd say continue working with it. I would say don't take any problems off. You probably won't memorize it. Go to memorize, Paxton? You gotta memorize? No. Do you know what to do after you find the axis of symmetry? After you find x? Vertex. Jump to the vertex. Great. This, which one is smooth? Yeah. Kind of a bummer of a point. It's really far away, so I'm gonna go by 2's when I make my graph. I feel like the answers are right in front of our faces. Yeah. I'm gonna make the table. I'm gonna put -4 in the middle. What point should go in my table? Jacob, do you know? Anything? All right. Yeah, 5 times we've been through these steps. That's pretty good. It's like almost quiz time. Too little. I mean, I don't know. 5 times walking through the same steps. You should really be getting this down now. Let's split it up. -6. Why don't Jahir and Jesus and Baden and your groups all plug in -6? Wait, this is what I want to do. Yeah. All right, you guys do -5 and you guys do -5. And then if you can get the right number out. I went ahead and I'm doing my x by 2, I'm doing my y by 2. So accommodate is 16 in the problem. How'd you guys do? I got the answers.
Teachers, please pardon this interruption for a few afternoon announcements. We have no bus changes today.
I'm still gonna say your answer.
Voting for
Can you
home
do up
support has
homework?
begun. Please log into your school's grade group for directions. To vote, you must access your account via WebNet. The first round of voting will close tomorrow at noon. Juniors and seniors, please take the ASVAB test. Find out who is failing, student services.
Make sure you write down your homework and do your work.
Have one question. Attendance or performance.
You guys,
Test card information meeting is today, 33105. Beginners and experts are welcome. Juniors and seniors, tutoring for the SAT October 13th. Available after school. Immediate notice, Monday through Thursday. Season back to her budget over a month. Did you get that worksheet?
Yeah, I just gotta print it. Oh, I got one.